To the nation with the mightiest rocket power belongs the conquest of space. Shortly after its establishment in 1958, NASA, the National Aeronautics and Space Administration, began the job of creating rocket power capable of thrusting skyward a spaceship weighing 3,000 tons. How much is 3,000 tons? As much as this nuclear submarine, or 24 jet airliners fully loaded with passengers, cargo, and crews. But such gargantuan power must also be as humanly reliable as possible, for men will ride the ship to the moon. Under the technical direction of the Marshall Space Flight Center, the task was assigned to Rocketdyne, a division of North American Aviation Incorporated. In California's Santa Susana Mountains, where Butterfield stages once rolled down rugged trails, Rocketdyne engineers had created America's largest propulsion field laboratory. On the ashes of campfires built here by the outlaw Joaquin Murrieta, other rocket engines had already begun their trials by fire. Anchored to test stands, engines poured forth their pillars of flame. Work on the giant engine, christened the F-1, began with studies of other Rocketdyne accomplishments in rocket power. From investigations made for the Air Force as far back as 1955 to space shots of the 60s, experts examined and evaluated results. Information from 20,000 engine and component tests was thoroughly reviewed, analyzed, checked. To the F-1, the Marshall Space Flight Center had assigned the mammoth task of lifting the mightiest rocket ship ever from launch pad into space. For this reason, NASA had placed the highest priority on the project. To achieve the tremendous push or thrust needed for this immense engine, data and design were precisely plotted. Steadily, systematically, design developed into a prototype. Harnessed here within the metal and might of this engine lay the outer space prestige of the United States. This new F-1 must perform perfectly, for more than just time and money are involved. Men's lives will depend on it. Since there is no air in outer space for a rocket engine to breathe, it must carry along its own. Liquid oxygen at 300 degrees below zero. At the same instant this frigid oxygen is flowing, however, an inferno of 5,000 degrees Fahrenheit is created inside the engine. A new generation of production techniques and tools had to be devised. New methods of manufacture, new adjustments, new ideas. Advanced metallurgy had to produce superior metals of great strength. The latest instruments and inventions were prepared and put to their purposes. Essential details were pictured in black and white. A myriad of matters were pinned down. The best talent and technologies were assembled. Tests were run for withstanding the tremendous acceleration of launch. Intense vibration, prodigious pressures, the vacuum of outer space, extremes of cold and heat. Yet all of these were merely samplings of the countless complexities to be solved. There was more, much more to fathom. To feed the F-1 with liquid oxygen and kerosene, pumps were needed, capable of forcing 3 tons of propellant into the engine in a single second. That's as much fuel as your automobile uses in an entire year. The combined power of these pumps would equal 30 diesel locomotives working together. There was more for the engineers to ponder. Because weight in a rocket is at a premium, each pump must be confined to a small, compact package. Entering the combustion chamber, fuel would have to burn with volcanic force to produce a thrust of 1,500,000 pounds. The equivalent power generated by 17 Hoover dams. Once unleashed, however, this titanic force must still be under absolute control. Thrust precisely delivered. Duration regulated to the fraction of a second. The engine must be instantly stopped when necessary by the push of a single button. To these formidable demands, the Marshall Space Flight Center had added the requisites of reliability, simplicity, and ruggedness to provide the utmost safety for the men who will ride atop the F-1 engines. And the F-1 must be adaptable to fit such giant spaceships as the advanced Saturn moon rocket now being planned by NASA. This Saturn, the C-5, will carry the Apollo spacecraft and its crew on the first expedition to the moon. Riding with the astronauts will be food, water, oxygen, power, air conditioning, communications equipment, scientific instruments, and a means for return home. Heavy shielding will protect them from deadly radiation. In addition, thousands of gallons of fuel will be contained within these tanks. Such a tremendous amassment of weight will call for the advanced Saturn to be 350 feet high, tall as a 30-story building. It will weigh 3,000 tons, 6 million pounds of takeoff weight, the heaviest load ever to lift off the Earth by its own bootstraps. How will such a stupendous task be performed? By clustering 5 F-1 engines together for the Saturn's first stage, creating 7.5 million pounds of thrust. Power equal to 85 Hoover dams. The intricacies of such a dynamic endeavor demand machines able to effect economies in money, minutes, and material. And shape high-strength metal to exacting requirements. And also, men. Skilled men to manipulate the machines. And men with trained minds to probe deeply into problems never known before. Hundreds of scientists and engineers, and more hundreds in manufacturing and administration, all directing their efforts and energies toward bringing into reality the F-1. From the mastery of 1,000 things never thought of before, from a multitude of materials newly discovered, invented, or adapted, from thought to tangible reality, the F-1 is no longer a drawing board dream. It exists now. The F-1 is a mighty metal fact. the result of 4 earnest years of work by the nation's most experienced rocket engine experts. In May 1962, the F-1 was successfully run at full thrust for full duration. Captive runs continue at the NASA High Thrust Test Area at Edwards, California. They will continue night and day, perfecting the F-1 for flight into a new dimension. With the F-1 engine, we will be ready to send our men to the moon and beyond. There is no end to space, and the moon is not our final target. Long before that landing has taken place, routes will have been plotted for expeditions far beyond it. As long as man seeks after knowledge and wisdom, there will be no ultimate goal. There will only be a series of steps, each reaching out a little farther into the vast realm of the unknown.